Okay, good morning, all of you. Am I audible? Yes, am I audible? Screen is visible.
Yes, ma'am.
Okay. So in last lecture, we have started numericals on shear force and bending moment diagram. Okay. So we have solved two numericals. First numerical is on how to draw shear force and bending moment diagram if simply supported beam, simply supported beam, simply supported simply supported beam, simply supported beam with central point load, with central point load. Okay, with central point load. For this particular case, the value of shear force which is equal to how much? Shear force which is equal to, yes, for this particular case, shear force which is equal to W by, yes, already we have solved, that's why I am asking. Yes, shear force which is equal to
WL by
WL by or W by. This is our simply supported beam and centrally point load is applied. So this is W, this is A point and this is B point. So shear force which is equal to W by 2 and bending moment which is equal to, that is maximum bending moment which is equal to, maximum bending moment which is equal to
WL by 4.
WL by 4. Okay, WL by 4. These values for simply supported beam with central point load. After that, we have solved second example. Simply supported beam with UDL throughout span. With UDL throughout span. Throughout span. Okay, throughout span. So this is the figure for this simply supported beam and uniformly distributed load W kilonewton per meter is applied. This is A point, this is B point. For this particular case, shear force which is equal to how much?
WL by 2.
Yes, WL by 2 and bending moment, that is maximum bending moment which is equal to, maximum bending moment which is equal to W L square divided by 8. So just you have to remember these two values and these two values also. Okay. So today we will solve next example, that is simply supported beam with uniformly varying load. With uniformly varying load. This is third type of load. So now we will solve example. Okay. So please write down. SFD and BMD, SFD and BMD, BMD for SFD and BMD for uniformly varying load, uniformly varying load, that is UVL. Okay, uniformly varying load. First we will draw figure and then we will solve. So first we will draw figure. So this is our simply supported beam AB and on that beam one uniformly varying load is applied. Okay, uniformly varying load. Okay. And the intensity of this uniformly varying load is W. Intensity of this uniformly varying load is W. So here the value is value is W. This is A point. This is B point. Okay. And span for this beam is L. Span is L. Okay. So here vertical reaction RA will be there and here vertical reaction RB will be there. So this is the question. Uniformly distributed load is applied here and we have to draw shear force and bending moment diagram for this particular figure. Okay. So whenever we will solve problem, at that time our step number 1. What is our step number 1? First, we will calculate reactions. So first step is reaction calculation. Reaction calculation. First step is reaction calculations. Okay. So whenever we will calculate reactions, at that time first we will apply summation FV which is equal to 0. That is, we have to take addition of all vertical forces which is equal to 0. Whenever we will apply this equation, at that time you have to remember upward force is positive and downward force we will consider as a negative. So by using these sign conventions, we have to take addition of all vertical forces. So these RA and RB going upward direction. So we will consider it as a positive. So therefore, RA plus RB. Now you tell me this W kilonewton force going upward direction or downward direction? Yes. Yes. This W kilonewton force is going upward or downward direction?
Upward.
Upward or downward?
Down.
Downward direction, because of this load is applied on that beam. So this is acting downward direction. So whenever force is downward, at that time we have to consider negative, minus. But here applied force is in triangular shape. So we have to take area of this triangle, and the area of triangle is 1/2 into base into height. So base is L into height is W. So WL which is equal to 0. Therefore, RA plus RB which is equal to, we will shift this 1/2 WL to right side. So WL by 2. So this is our equation first. After that, second equation we have to apply, and second equation is we have to take movement at any point. So we will take movement at A point. So summation movement at A which is equal to 0. We will apply summation movement at A which is equal to 0. Whenever we will take movement, at that time we have to use sign convention. Clockwise movement we will consider positive and anti-clockwise movement we will consider negative. So we will take movement about A and we will start from this B point. So now you tell me, this RB creates clockwise movement towards A or anti-clockwise movement? This RB creates clockwise or anti-clockwise movement towards A?
Anti-clockwise.
Anti-clockwise. So you observe here, this RB creates anti-clockwise movement. So minus RB into perpendicular distance is L. Okay, L. After that, next, this load. Okay, this load creates clockwise movement towards A. Clockwise movement towards A. So first we will take load and then we will multiply by distance. So load means area of this particular figure, area of this triangle, and area of this triangle is 1/2 into WL into, it will act as its CG. Okay, it will act as its CG. So we will consider from this A point. Okay, so from this A point, it will act at 1/3. So L by 3, which is equal to 0. I have not considered here RA. Why I have not considered here RA? Anyone?
Distance 0. Distance 0.
We are calculating movement at that particular point. So force is there, but perpendicular distance is 0. That's why this movement will get 0. That's why I have not considered. Okay, now we will shift this RB into L to right side. Okay, RB into L to right side. So WL into L, that is WL square. Okay, WL square divided by 3 into 2 is 6, which is equal to RB into L. So 1L and 1L gets cancelled. So therefore RB, which is equal to how much? Yes, therefore RB, which is equal to WL upon 6. So this is the value of reaction at B point. So therefore RB, which is equal to WL upon 6. Once you got this value of RB, after that we have to put this value in equation 1. Okay, so put RB in equation 1. RB in equation 1. So our equation 1 is RA plus RB, which is equal to WL divided by 2. Okay, so RA plus the value of RB is WL divided by 6, which is equal to WL divided by 2. So therefore RA, which is equal to WL by 2 minus WL by 6. So first we have to make same denominator. So for that we will multiply by 3 to this numerator as well as denominator. Therefore RA, which is equal to 3WL divided by 6 minus WL divided by 6. So 3 minus 1. Therefore RA, which is equal to 3 minus 1 is 2 WL as it is divided by 6. 2 1s are 2, 2 3s are 6. So therefore RA, which is equal to WL divided by 3. So this is the value of RA, and RB value already we have calculated. Once we got value of RA and RB, then we are able to find out the values of shear forces and bending moments. Okay, so we will write values of RA and RB here. So RA, which is equal to WL by 3, and RB, which is equal to WL by 6. Okay, up to this point, anyone have doubt? Anybody having any doubt? Yes. Anybody having doubts? Okay. If no doubt, we will move towards next step, that is shear force calculations. Second step is shear force calculations. Second step is shear force calculations. Shear force calculations. Shear force calculations. Okay. So first we will calculate shear force at A point. First we will calculate shear force at A point. Now you tell me shear force at A, which is equal to how much? Shear force at A.
WL by 2 kilonewton.
Shear force at A, which is equal to shear force at A, which is equal to. Okay, so whenever we will calculate shear force, at that time clockwise rotation is positive and anti-clockwise rotation is negative. Okay, we will consider anti-clockwise rotation is negative. So this RA creates clockwise rotation. So shear force at A, which is equal to plus WL by 3 kilonewton. Okay, this is the shear force at A. After that, we will take section at X from distance A. We will take section at X from distance A. So shear force at X, shear force at X from A, shear force at X from A point, Okay. So we will take section here. So I will draw figure separately here. So suppose this is our beam simply supported, and on that one uniformly varying load is applied. Okay. And this is the W and this is L. So we have to take section. Suppose we have taken section here. This is XX distance. Okay. This is XX distance. So suppose this distance is X meter. So remaining distance which is equal to how much? Remaining distance which is equal to how much? Anyone?
X by 2.
Okay, total distance is L. Okay, total distance is L, and out of that up to this point X. So remaining distance will be.
L minus X.
Okay, good. So this distance is L minus X. This is correct. Okay. So this is the figure, and we have taken section here at X distance. Okay. So we have to find out shear force at X distance. We have to find out shear force at X distance. So for this particular figure. Now you observe this particular section is trapezoidal section. Okay, this is trapezoidal section likewise. Okay, so suppose this is A portion, this is B, and this is height. Okay, this is height of this particular trapezoidal section. So you observe here for L distance the value is W. So we have to find out for this X distance this is W1. Okay, we have to calculate this WN, this W1, this W1. So how to calculate this? बघा टोटल L साठी व्हॅल्यू आहे W. तर मग आपल्याला इथे काय करायची आहे तर X डिस्टन्स सॉरी हे जे काय आपलं डिस्टन्स शिल्लक राहिलेलं आहे L मायनस एक्स डिस्टन्स हे L मायनस एक्स त्या ह्या L मायनस एक्स साठी W1 ची व्हॅल्यू किती असणार आहे ते फाइंड आउट करायचं. तर आपण इथे काय करूया L डिस्टन्स साठी हाईट किती आहे W. ओके L डिस्टन्स साठी व्हॅल्यू किती आहे आपली W. For L distance value is W. So we will find out for this L minus X. For this L minus X which is equal to W1. बघा ह्या L minus X distance साठी आपण W1 assume केलं. But therefore W1 which is equal to we will cross multiply here. So W in bracket L minus X divided by L. So this is the value of W1. Okay, got it? Value of W1. Now we will calculate shear force at X from A distance. Okay, shear force at X from A distance. So which is equal to, now we will calculate here, which is equal to WL by 3, WL by 3. Okay, this RA force as it is, RA force as it is WL by 3 minus. Now we will take area of this trapezoidal section. We will take area of this trapezoidal section. So A means we will consider W as it is. Okay, W plus. Okay, plus we have to put value here W1. So the value of W1 is W in bracket L minus X divided by L. Okay. Into height is X distance. Height is X distance divided by 2. So A plus B, area is A plus B. Area of trapezoidal section is A plus B divided by 2 into height. So this A plus B divided into H divided by 2. So this is A plus B divided by 2. Now we will solve this equation. So which is equal to WL by 3 minus, we will make same denominator. Okay, we will make same denominator. So here 1, we will take cross multiplication. So W into L is WL. Okay, plus W in bracket L minus X as it is. Now divided by L. Okay, into X by 2. Okay, into X by 2. After that, I will multiply by this X to this whole bracket. So therefore, WL divided by 3 minus. Okay, minus in bracket. WL into X is WLX plus W into L into this X. So WLX and W into X. So minus WX square minus WX square divided by 2L. This is bracket close. Okay, this is bracket close. After that, next step. Now we will simplify again this equation. So please wait. Okay. So after that, which is equal to, I will write this previous equation. WL by 3, WL by 3 minus in bracket WL plus WL minus WX divided by L into X by 2. Okay. So which is equal to WL by 3 minus, we will first multiply by this X to this whole bracket. So WLX plus WLX minus WX square divided by 2 into L is 2L. So bracket close. Now we will take this WL. Okay, this one WL and this one WL, that is 2 WL. But whenever we will multiply by this minus 2, this bracket, so at that time WL divided by 3 minus 2 WLX. बघा हे minus 2 WLX कसा असणार आहे? Minus plus minus and minus plus minus. So this one and this one is 2 WLX. Okay, after that this minus into minus is plus WX square divided by 2L. WX square divided by 2L. Okay, WX square divided by 2L. Now you observe here X, highest power of X is how much? Highest power of X is how much? Yes. Highest power of X is how much? 2. So highest, okay, we will write here. So highest power of X is 2. Highest power of X is 2. That is, connection is which type of connection? That is connection between 2 points each. Connection between 2 points each. Now you tell me, connection between 2 points each.
Parabolic.
Okay, good. So whenever X power is 2, at that time connection is parabolic. Connection is parabolic. So we have to prove it. Okay. So connection is parabolic and this is general equation. This is general equation. Okay. After that, we will find out shear force at X which is equal to L distance. Okay. We will find shear force. We will find shear force at X. Shear force at X. Shear force at X. That is, we will put X which is equal to L. We will put X which is equal to L in this general equation. Okay. So our general equation is WL by 3 minus 2WLX divided by, okay, plus WX square divided by 2L. Okay. Instead of this X, we will put here L because of we are going to find out shear force at L distance. So WL by 3 minus 2WL into X means L plus W into L square divided by 2L. So which is equal to WL divided by 3 minus 2WL into L, that is 2WL square plus WL square divided by 2L. 2L. Okay. Now 2W. Yes, anybody having doubt? Okay. So here this 2WL square is negative and this is plus WL square. So minus 2 plus 1, that is WL divided by 3 minus WL square divided by 2L is remaining. WL square divided by 2L. So this L and L gets cancelled. So what is remaining after that? WL divided by 3 minus WL by 2. After that, we will make same denominator. So which is equal to 2WL minus 3WL divided by 6. 2WL minus 3WL divided by 6, which is equal to. So minus 3WL plus 2WL, that is minus WL by 6. So shear force at L distance, that means shear force at B point. Therefore, shear force at B, which is equal to how much? Minus WL divided by 6 kilonewton. Okay, got it? Anybody having doubt? But this shear force before reaction, this shear force before reaction, Now we will find out shear force after reaction. Okay, shear force after reaction. So shear force at B, but after reaction, So which is equal to, okay, shear force at B after reaction. So before reaction, shear force is how much? Minus WL by 6. Okay. And after that, we will consider reaction. So reaction at B, which is equal to plus WL by 6. Plus WL by 6. So minus WL by 6 plus WL by 6, which is equal to 0 kilonewton. So shear force at B after reaction, which is equal to 0 kilonewton. Okay. And last, we will find out shear force is 0 at X. Okay. So we will find out where shear force is 0. Where shear force is 0, because of at that point bending moment is maximum. So we will find out this point. So next step is shear force is 0 at X distance. So we will assume shear force is 0 at X distance. So for this, we will take our general equation. So our general equation is WL by 3 minus 2WLX minus 2WLX plus WX square divided by 2L. So this is our general equation. And in this equation, we will put the value shear force, which is equal to 0. Okay, shear force, which is equal to 0. Okay, please wait. Okay. So after that, we will make same denominator. So we will multiply by 2L to this side and 3 to this side. So 2WL into L minus 3 into 2 is 6WLX. Then plus 3 into 3WX square divided by 3 into 2 is 6L, which is equal to 0. Now we will shift this 6L to right side. So what we'll get? WL square, 2WL square minus 6WLX plus 3WX square, which is equal to 0 into 6L. That means right side is totally 0. So 2WL square minus 6WLX plus 3wx square, which is equal to 0. Now, this is the equation, quadratic equation we have to solve. Okay, you know that quadratic equation, how to solve? So, the quadratic equation is likewise ax square plus bx plus c, which is equal to 0. X square plus bx plus c. You observe here. Ax plus bx plus c, which is equal to 0. And how to solve this equation? So x1 comma 2, which is equal to x1 comma 2, which is equal to minus b plus minus square root of b square root of b square plus ac divided by 2a, plus ac divided by 2a. So we have to solve this equation by using this. Okay, so we will solve this equation. We will put values here. So x1 comma 2, which is equal to minus b. We will first write value of a, b, c, and then we will solve. Okay, so the value of a. Now you tell me value of a, which is equal to how much? 2w. Yes, value of a, which is equal to 3wx square. So this is the value of a. Okay, this is the value of a. So value of a, which is equal to 3w, we will consider this is the value of a. Then value of b, which is equal to minus 6wl, minus 6wl, and value of c, which is equal to as it is w2wl square. So we will put this value in this equation. So x1 comma 2, which is equal to minus, the value of b is minus 6wl plus minus square root of b square. So value of b is minus 6wl square bracket square plus a into c. The value of a is how much? Value of a is 3w into value of c is 2wl square bracket close and whole divided by 2a, that is 2 into 3w. Okay, so x1 comma 2, which is equal to minus minus, we will get plus. So 6wl plus minus. Okay, so the square of this 6 is 36 and 2 into wl into 2 into, sorry, here 4 I have remain. So b square plus 4ac, I have remained this 4. Okay, so 4 into 3, which is equal to 12. 12 into 2, that is 24. Okay, so under bracket, what is 36wl square plus 4 3s are 12 and 12 2s are 24wl square. Okay, and whole divided by 2 into 3 is 6w. 2 into 3 is 6w. Okay, again we will simplify this. For that I will take just new slide. Okay, so what is our equation? Once again I will write here x1 comma 2, which is equal to 6wl plus minus square root of 36wl square w square l square minus 24w square l square divided by 6w. Here also you make some changes. Here 24 W square L square is there, and here also, okay, we have written here W square L square. Okay. So now we have to simplify this equation. So x 1 comma 2, which is equal to, okay, we will take 6WL as it is, plus minus, okay, square root of this 6, 36 and 24. So after that we will get value is how much? 36 minus 24 is square root of 12. Okay, so 12 W square L square divided by 6W divided by 6W. So the value of this square root of 12 is how much? X 1 comma 2, which is equal to 6WL plus minus. The value of this 12 under root of 12 is how much? Highest, calculate and tell me square root of W, which is equal to how much? Square root of W, which is equal to, sorry, square root of 12, which is equal to, calculate and tell me fast. Yes, square root of 12, which is equal to how much? 3.46. Okay. So the value of the square root of W is 3.46, and W square, that is W, and L square is L, divided by, we will take this 6W as it is. So after that you put this value in calculator and find out X. So you will get X, which is equal to, first answer is 1.5L and second answer is 0.423, 0.423 L. So this 1.45 L is not, okay, because of this is vary from our beam. So but this X, which is equal to 0.423 L, is correct. So this is the distance from A point. Okay, we will convert from B point for calculation. So at this point shear force is 0. So X, which is equal to 0.423 L from A point, at this point shear force is 0. Why we have calculated this? Because of where shear force is 0, at that point bending moment is maximum. That's why we have calculated this distance. Okay. So now shear force calculations are over. Next step, our step number 3 is bending moment calculations. Step number 3 is bending moment calculations. Bending moment calculations. Bending moment calculations. So for this, again I will draw figure here. So this is our simply supported beam, and on that beam this is uniformly varying load is applied here. This is intensity W, this is A point, this is B point. Okay, at A point reaction is WL by 3, and at B point reaction is WL by 6, WL by 6. So first we will calculate bending moment at B. So now you tell me bending moment at B, which is equal to how much? Bending moment at B. Yes. Bending moment at B, which is equal to how much? फक्त ऐकण्याचं काम केलं तर तुम्हाला हे काहीच समजणार नाही. ज्यावेळी मी क्वेश्चन विचारते त्यावेळी तुम्ही काहीतरी आन्सर केलं तर टू वे कम्युनिकेशन असेल तर तुम्हाला थोडं इझी जाईल समजण्यासाठी. सो बेंडिंग मोमेंट ऍट बी, विच इज इक्वल टू हाऊ मच? Okay, so whenever we will calculate bending moment, do calculations for bending moment, at that time sagging we will consider positive and hogging we will consider negative. So this W creates sagging. Because of this, W pushes upward. When force pushes upward, at that time sagging curvature is occurred. So this WL by 6 pushes upward, but perpendicular distance is 0. That's why bending moment at B, which is equal to 0 kilonewton meter. Bending moment at B, which is equal to 0 kilonewton meter. Okay. After that, we will calculate bending moment at x distance. Bending moment at x from B. Bending moment at x from B. From B. For that, I will draw figure here. Bending moment. So this is our B point, and here WL by 6 load is applied, and we have taken section here XX. Okay, XX, and this is suppose our value. So up to this point, this distance is X. Okay, and remaining is our likewise. Okay, remaining beam is our likewise. So we have taken section up to this point only. So this portion we will consider. Okay, and this distance is how much? So this distance is L minus X, because of total span is L. Out of that we have considered this X. So L minus X. Okay. So for L distance, this height is W, but we have to find out for this X distance. We have to find out for this X distance. So this is we will consider W1. Again here we have to apply same concept. For L distance, height is W. Okay, height is W. So for X distance, height is W1. Therefore, the value of W1 which is equal, W1 which is equal to Wx divided by L. That means this height is Wx into, sorry, Wx divided by L. Now we will calculate movement at this XX distance. Okay, so bending moment which is equal to, bending moment which is equal to, bending moment which is equal to. So we will take movement from this B point. So this B point pushes upward. When force pushes upward, that means automatically we will get positive energy. So this creates sagging movement. So plus. So plus WL by 6 into perpendicular distance is only X. Perpendicular distance is X. Okay. After that, now the load of this particular figure, and this figure is triangular portion. So, and this pushes downward. When this force is pushes downward, at that time sagging nature is occurred, and this is minus. So minus 1/2. Okay, this shape is triangular. So area of this shape is 1/2 into base into height. So 1/2 into X into height is already, base is X and height is how much? Wx divided by L. Already we have calculated. This is the load, but we have to multiply by perpendicular distance. So this distance is from this point. This is X by 3. X by 3. Okay. Now we will resolve this. X by 3. So we will resolve this. So bending moment which is equal to, bending moment which is equal to WL into X, that is WLX divided by 6 minus W into X into X into X. So how much? W X cube. 1, 2, 3. Okay, Wx cube divided by 3 into 2 is 6 and 1 L is there. So L, 6L. Now you tell me here X, highest power of X is how much? Highest power of X. Yes, highest power of X. Highest power of X. Someone has replied, okay, highest power of X is 3. X which is equal to 3. That is connection between 2 points is cubic polynomial. Cubic polynomial. Please remember this. If X raised to 3, that is highest power of x. At that time, connection between 2 points is cubic polynomial. Cubic polynomial. Okay. So this is here. Now we will find out bending moment at A point. Okay, bending moment at A point. So for finding out bending moment at A, the value of x, which is equal to how much? Anyone please suggest? We have to find out bending moment at A, and I have to put the value of x. So value of x, which is equal to how much? I will put here. Anyone? Yes, please. Okay. This equation for bending moment at x distance. Now we have to find out bending moment at this A point. So for finding out this bending moment at A, we have to put x, which is equal to how much? After putting x, which is equal to what value, we will get shear bending moment at A point. काय put करावी लागेल वो value? कोण सांगू शकतं? So next point is bending moment at A. Bending moment at A, which is equal to x ची व्हॅल्यू काय पुट करावी लागेल म्हणजे आपल्याला बेंडिंग मोमेंट A मिळेल. Yes, anyone? काय येतंय का लक्षात? x ची व्हॅल्यू किती पुट केली म्हणजे आपल्याला बेंडिंग मोमेंट A पॉइंटला काढता येईल. रोहित, स्नेहल, सायली, श्वेता, चैत्राली, आदिशक्ती, साक्षी कुरके, ऋतुजा पवार. We have to find out shear force at A, and I have to put value of x, which is equal to how much in this equation. x ची व्हॅल्यू काय पुट केल्यानंतर आपण बेंडिंग मोमेंट फाइंड आउट करू शकतो A पॉइंटला? किती पुट करावी लागेल? x, which is equal to, सांगू शकताय का कोण? Okay, someone replied. Yes, good. X, which is equal to L. After putting x, which is equal to L, we will get the value of bending moment at A point. Okay, so we will put the value of x, which is equal to A. So that is put x, which is equal to L in general equation. In general equation for finding out bending moment at A. After putting the value of x, which is equal to L in this general equation, we will get the value of bending moment. Okay, so we will put the value of L in this equation. So bending moment at A, bending moment at A, which is equal to our general equation, which is equal to, general equation is WLX divided by 6 minus WX cube divided by 6L. So here, instead of this x, we will put the value of x is L. So for we will get bending moment at A. So I will put value here, which is equal to WL into L divided by 6 minus W into this value of x is L. So L cube divided by 6L. Okay. So now we will simplify this. So W into L, that is W, yes, WL square by 6 minus W into L cube. So WL cube divided by 6L. So 1L and 1L gets cancelled. So what is remaining? WL square divided by 6 minus W. 1L gets cancelled. Yes, L square. So WL square divided by 6. So plus WL square minus WL square, which is equal to 0. So bending moment at A point, which is equal to 0 kilonewton meter. Okay. Anybody having doubt? So bending moment at A which is equal to 0, bending moment at B which is equal to 0. Now we have to find out maximum bending moment. Okay, so for this finding out maximum bending moment, one relation is there. Anyone please? What is the relation? Which relation we will use for finding out maximum bending moment? Where maximum bending moment is occurred? Where? At which point? Yes, anyone? कुठल्या पॉइंटला बेंडिंग मोमेंट मॅक्सिमम असते? Yes, at which point bending moment is maximum? बघा आपण लिहिलं होतं कुठल्या पॉइंटला बेंडिंग मोमेंट मॅक्सिमम असते? ज्या पॉइंटला शियर फोर्सची व्हॅल्यू 0 असते. ज्या पॉइंटला शियर फोर्सची व्हॅल्यू 0 असते त्या पॉइंटला मॅक्सिमम बेंडिंग मोमेंटची व्हॅल्यू आपल्याला मिळते. ओके, सो नेक्स्ट पॉइंट इज वी विल फाइंड आउट मॅक्सिमम बेंडिंग मोमेंट. ओके, मॅक्सिमम बेंडिंग मोमेंट. फॉर दिस I will take new slide. Wait. So we will find out maximum bending moment. Maximum bending moment. Maximum bending moment. So for this we have to put x which is equal to already we have calculated here. I will show. Okay, the shear force is 0 at x. म्हणजे आपण इथं कॅल्क्युलेशन केलेले आहे. शियर फोर्स हा x डिस्टन्सला 0 आहे, पण ते x चं डिस्टन्स किती आलेले आहे आपल्या इथं? x which is equal to 0.423 L. 0.423 L. ओके, पण ते आपलं A साइड कडून होतं, आपल्याला B साइड कडून पाहिजे आहे. ओके, सो फर्स्ट वी विल कन्वर्ट दिस. सो पुट x which is equal to 1 minus 0 point or L minus 0.423 L. So x which is equal to how much? 1 minus 0.423, that is 0.577 L. So after putting this value, we will get maximum bending moment value. So our general equation is WL divided by WLX divided by 6, WLX divided by 6 minus WX cube divided by 6L, WX cube divided by 6L. Here we will put the value of x, and the value of x is 0.577 L. So which is equal to WL into the value of x is 0.577 L divided by 6 minus W into x. So value of x is 0.577 L cube divided by 6L. Okay, so 0.577 L, 0.577 W into L, that is WL square divided by 6 minus, now you make the cube of this 0.577, cube of this 0.577 is how much? Yes, 0.192. Okay. So 0.192 WL cube. WL cube divided by 6L. So 1L gets cancelled. So what is remaining? 0.577 WL square divided by 6 minus 0.192 WL square divided by 6. So now denominator is same. WL square is common. So plus 0.57 minus 0.192 divided by 6, which is equal to how much? WL square. So 0.577 minus 0.192. We will take this WL common, WL square, and divided by 6. So now you tell me which is equal to how much WL square. You calculate this and you tell me maximum bending moment which is equal to how much WL square. Yes, which is equal to how much WL square? 0.577 minus 0.192 divided by 6, 0.0642. Okay. So maximum bending moment is 0.0642 WL square. So this is the maximum bending moment value. Now our shear force calculations and bending moment calculations are over. We will draw shear force diagram and bending moment diagram. So for this, first I will draw our given beam. So this is given simply supported beam, and on that beam one uniformly varying load is applied. Okay, uniformly varying load is applied. So this is load W. Okay. So this is our A point. This is B point. At A point, reaction is how much? At A point, reaction is RA, which is equal to W. Yes, RA, which is equal to WL by 3, and RB, which is equal to WL by 6. Okay, and this is W. First, we will draw shear force diagram. So whenever we have done calculations for shear force, at that time x raised to power is 2. So our diagram is cubic parabola. Okay, our diagram is cubic parabola. So for that, sorry, only parabola. We will draw first baseline. After that, the value of shear force at A point. Value of shear force at A point is WL by 3. So up to this point, WL by 3. So this is suppose WL by 3. The value of shear force at A point is WL by 3. WL by 3. After that, shear force is 0. Shear force is 0 at this point, and this distance is 0.423 L from this A point. From this A point. Okay. And shear force at B before considering reaction. Before considering reaction is minus WL by 6. So value is here, suppose. Okay. Minus WL by 6 and shear force at B is 0. Shear force at B is 0. And here minus WL divided by 6. Now we will draw. So this is parabolic figure. Okay. So this is in negative and this is in positive. Okay, so here shear force is 0 kilonewton. Here also 0. So this diagram is shear force diagram. Okay, shear force diagram. After that, we will draw bending moment diagram. We will draw bending moment diagram. So for drawing bending moment diagram, x raised to power is how much? X raised to power is 3. So we have to connect 2 points as a cubic polynomial. As a cubic polynomial. So first I will draw baseline and then we will draw figure. So suppose this is our baseline. Okay. So now you tell me bending moment at A point which is equal to? Yes, bending moment at A 0. Bending moment at B 0 and maximum bending moment. So where maximum bending moment is occurred? At shear force is 0. So at this point maximum bending moment value is 0.0642 WL square. WL square. And connection between 2 points is cubic polynomial. So likewise, cubic polynomial. Cubic polynomial. So this figure is cubic polynomial. Cubic polynomial. And this is which type of nature is there? Parabolic. Parabolic. Okay, so this is the bending moment diagram. This is the bending moment diagram. Okay, so just you have to remember shear force for uniformly varying load is WL by 3 at A point and minus WL by 6 or 0 at B point. 0 at B point. Okay, please remember. And maximum bending moment is 0.0642 WL square. So at least you remember these values and the shape of the bending moment and shear force diagram, because of definitely one MCQ will be asked on this shape of bending moment diagram or shear force diagram. So if uniformly varying load is applied, at that time shape of shear force diagram is parabolic and bending moment diagram is cubic polynomial. Okay, anybody having not understand this problem, don't take tension, because of this problem will not ask in university examination, but I have taken for GATE point of view. But for MCQ, one MCQ will be asked on shape of shear force diagram or shape of bending moment diagram. Okay, now I will give time for writing, so please write down. Then we will take last problem on simply supported beam, that is couple applied. Okay, please write down. let me know after your writing is over. So we will take next example. Huh? Okay, if your writing is over, shall I take next example? Yes. Your writing is over or you want time? Yes, give me reply. Yes, please, anyone. Writing is over or you want time for writing? Hmm? Yes. Okay, over. Then we will take next example. Wait. Okay, so last type load is remaining. Which type of load is remaining? Anyone? Which type of load is remaining for finding out shear force and bending moment values, and also for drawing shear force diagram and bending moment diagram? Which type of loading is remaining? Yes. Okay, we have drawn as a shear force diagram and bending moment diagram for point load, uniformly distributed load, uniformly varying load, and last type is remaining. That is moment couple. So shear force diagram and bending moment diagram for moment couple. For moment couple. Moment couple. Okay. So I will draw figure. You can also draw. Then we will solve this. So suppose this is simply supported beam, and on that beam movement couple is applied. Okay, but this couple is not applied at center. This is applied at some distance. Okay, so this is A and B. This is A support and this is B support, and here movement couple is applied. So I will mark here M, and we will mark this point as a C. We will mark this point as a C point. Okay. So distance from A to C. Distance from A to C is A, and distance from C to B is B. Okay, is B. Now you tell me, our first step is, what is our first step? Yes, tell me fast. What is our first step? Reaction calculation. So first step is reaction calculations. Reaction calculations. Whenever we will calculate reactions, first step at that time, summation FV, which is equal to 0. So upward forces positive, downward forces negative. So this RA and RB going upward. So RA plus RB, RA plus RB. This M will considered or not here? ही M ची व्हॅल्यू घ्यायची का नाही घ्यायची? M is force or not? So M is movement. This is not force. So RA plus RB, only that much vertical forces are there. So RA plus RB, which is equal to 0. This is our equation 1. After that, we will apply second equation, summation movement at any point which is equal to 0. So for this sign convention, clockwise movement positive, anti-clockwise movement negative. Okay. So we will take movement from this B point to A point. So this RB creates anti-clockwise movement. So minus RB into perpendicular distance is total span of this beam is L meter. So L. After that, this movement. After that, this movement is there and this is clockwise. So plus m. Okay. Here not need to multiply by perpendicular distance because of movement is given. So minus RB into L, which is equal to 0. Now we will shift this RB into L to right side. So M, which is equal to RB into L. So therefore RB, which is equal to RB, which is equal to M divided by L. So this is the value of reaction at B point. RB, which is equal to M divided by L. Now we will put this RB value in equation 1. So put RB in equation 1. In equation 1. So our equation 1 is RA plus RB, which is equal to 0. So RA as it is plus M divided by L, which is equal to 0. Therefore RA, which is equal to, therefore RA, which is equal to how much? Therefore RA, which is equal to minus M divided by L, minus M divided by L, minus M divided by L. And this minus sign indicates this reaction going downward direction. This reaction going downward direction because of our movement is clockwise movement. Okay, movement is clockwise. So for balancing this, required movement is anti-clockwise. That's why value of RA is minus M upon L, minus M upon L. Okay, so these are the values of RA and RB. So RB, which is equal to M by L, and RA, which is equal to minus M by L. तर हे निगेटिव्ह साइन काय आहे? तर मुवमेंट क्लॉकवाइज आहे, त्याला अपोजिट साठी अँटी क्लॉकवाइज पाहिजे म्हणून इथे RA चं साइन काय आलेलं आहे? मायनस. सो दीज आर द व्हॅल्यूज ऑफ RA and RB. After that, we have to do calculations for shear force. Okay. So step number 2, shear force calculations. Step number 2 is shear force calculations. Shear force calculations. Shear force calculations. We will calculate shear force. Okay. So first we will calculate shear force at A. Shear force at A. So shear force at A, which is equal to shear force at A, which is equal to. So at A, this RA creates anti-clockwise movement. So whenever we will calculate shear force, at that time clockwise rotation positive and anti-clockwise rotation negative. So this RA creates anti-clockwise rotation. So shear force at A, which is equal to minus M divided by L, minus M divided by L, minus M divided by L, minus M divided by L kilonewton. Okay. After that, we will calculate shear force at B. Shear force at B before RB. Shear force at B before RB. So shear force at B. Shear force at B, but before RB. Before RB. That means without considering the value of RB. So now you tell me, throughout this span, only one load is there. The value of RA is there. Okay. After that, no any load is there. So before RB, the value of shear force as it is minus M divided by L kilonewton. After that, next we will calculate shear force at B, but after RB. But after RB. That means by considering RB, which is equal to. So before this RB, shear force is minus M divided by L. And this RB creates clockwise rotation. RB creates clockwise. So plus M divided by L, plus M divided. So this RB force is pushes upward, that is up clockwise. So here value of RB is plus ML. So minus ML plus ML which is equal to 0. So shear force which is equal to 0 kilonewton at B. So these are the calculations of shear force. Okay. So you observe here whole values are in negative. So our shear force diagram is negative. Shear force diagram is negative because of all values are negative here. After that, next step number 3. What is our step number 3? Step number 3 is bending moment calculations. Bending moment calculations. So first we will calculate bending moment at B. Okay, bending moment at B. So bending moment at B, which is equal to, whenever we will calculate bending moment, sign convention, sagging positive and hogging nature negative. So this RB pushes upward. So when force is pushes upward, at that time positive energy we will get. So this is sagging type of nature. So here force is the M divided by L, but perpendicular distance is 0. That's why bending moment at B, which is equal to 0 kilonewton meter. 0 kilonewton meter. After that, we will find out bending moment at C. Bending moment at C, but before M. Okay, bending moment at C. Bending moment at C, but before M. But before M. Before applying M, which is equal to. Okay. So suppose this is our figure for this. So here M upon L is applied. This is B distance and we have taken here section XX. Okay, we have taken here section XX. So this again RB pushes upward. So value is M by L into perpendicular distance is B. Perpendicular distance is B. Suppose we assume we have taken section. So bending moment at C before M is M by L into B kilonewton meter. But we have taken assumed section at X distance. So bending moment which is equal to bending moment which is equal to how much? Suppose we have taken section at X distance. So bending moment which is equal to M divided by L into X. Okay. And here X to the power is 1. So if X to the power is 1, at that time connection is which type of connection? X raised to 1. That is connection is which type of connection? Connection is inclined straight line. Connection is inclined straight line. Inclined straight line. Please remember, inclined straight line. Connection is inclined straight line. So the bending moment at C is M by L into B, and here the power of X is 1. So connection is inclined straight line. After that, we will calculate bending moment at C after M. So bending moment at C, but after M. After M. After M. So bending moment at C after M. So for this figure is likewise. So here M by L. Okay, M by L, and here M is applied, M, and this distance is B. Okay, now we will take movement. So which is equal to this M pushes upward, so plus M by L into perpendicular distance is B, and this M pushes downward, so minus M kilonewton meter. So this is the bending moment from this side. Suppose we will find movement from this side. We will find movement from this side. Or okay, or another choice is with you. So only here one load is applied, minus M by L. Minus M by L. Okay. So bending moment which is equal to bending moment which is equal to. So this pushes downward. So minus M divided by L minus m divided by L into perpendicular distance is how much? Minus m divided by L from this point to C point. Perpendicular distance is A. So minus m divided by L into A. So these both are the same. Okay. You just verify. You put here value of this B is L minus A. You put here value of B is L minus A and you cross verify, you will get same answer. So either you find out bending moment from left side or right side, you will get same value. Okay. So bending moment at C, which is equal to minus ml divided by A. Now our shear force and bending moment calculations are over. Now we will draw bending moment diagram and shear force diagram. Okay. So I will draw here figure. So first we will draw our given beam. So this is our given beam AB, simply supported beam AB, and one moment couple is applied. One moment couple is applied here. So this is A point, this is B point, and one moment couple is applied here. This is M and this is C point. This distance is A distance and this distance is B distance. Now we will extend lines. So easily we will draw figure. Okay. First we will draw shear force diagram and then bending moment diagram. So first we'll draw baseline. Okay, so all values of shear forces are negative. So our bending moment diagram is below baseline. So shear force at A is minus m by L and shear force at B is again minus m by L. So shear force diagram is rectangular nature, but whole is in negative nature. Whole is in negative. Okay. So this is our shear force diagram. So this is our baseline. Here minus m by L value is there. Here also minus m by L. Okay. And whole diagram is in negative. So this is shear force diagram. This is A point. This is B point. Okay, after that we will draw bending moment diagram. So for drawing this bending moment diagram, first we will draw baseline. Okay, we will draw baseline. And here for drawing this bending moment diagram, x raised to power is 1. So our connection between 2 points is inclined straight line. Inclined straight line. So bending moment at A point is bending moment at A point is 0. Bending moment at B point is 0. And bending moment at C. Bending moment at C before applying moment value is M into B divided by L. And from this side value is M into A divided by L. And connection is inclined straight line. Inclined straight line. So we will draw it. From this point, MA divided by L, and from this MB divided by L. So this is diagram, bending moment diagram. This part is in negative and this part is in positive nature, and this is bending moment diagram. This is bending moment diagram. So please write down fast. Okay, your writing is over. Shall I take next point? Yes. Okay, writing is over or you want time? Okay, please write down next point. For that, I will stop share and then I will share new screen. Okay, screen is visible. Yes, screen is visible to you.
Yes, ma'am.
Okay, now this slide is visible. Which slide is visible to you now? Yes, at least read sentence, na. General guidelines on construction of SFD and BMD. This slide is visible to you. Yes. Okay, please write down next point. General guidelines. General guidelines on construction of. General guidelines on construction of shear force diagram. Shear force diagram and bending moment diagram. And bending moment diagram. General guidelines on construction of shear force diagram and bending moment diagram. Okay, so in that first point, in that first point, in that first point, I will read. Okay, so the load, Swalpaviram, shear and bending moment diagrams, shear and bending moment diagrams, shear and bending moment diagrams should be constructed, should be constructed, should be constructed one below the other, one below the other should be constructed, one below the other, one below the other, Swalpaviram, one below the other, one below the other. Please wait, I will share once again. Okay, now it is visible. Now is it visible? Okay. So write down first point in general guidelines on construction of shear force and bending moment diagram. So our first point is the load, Swalpaviram, shear and bending moment diagrams, shear and bending moment diagrams should be, shear and bending moment diagrams should be constructed one below the other, constructed one below the other, one below the other, Swalpaviram, in that order, in that order, in that order, Swalpaviram, all with the same horizontal scale, all with the same horizontal scale, all with the same horizontal scale. So under this point, we have to remember that we have to draw shear force and bending moment diagrams one below the other. ओके, म्हणजे आपल्याला काय करायचंय तर शिअर फोर्स आणि बेंडिंग मुवमेंट डायग्राम जे आहेत त्या शिअर फोर्स आणि बेंडिंग मुवमेंट डायग्राम एका पाठोपाठ एका खाली एक काढायच्या. म्हणजे आपला हा बीम दिलेला असेल तर त्या बीमच्या खाली शिअर फोर्स डायग्राम आपण ड्रॉ केली पाहिजे आणि त्या बीमच्या खाली बेंडिंग मुवमेंट डायग्राम सुद्धा ड्रॉ केली पाहिजे. म्हणजे वन बिलो अदर, जिथे आपण शिअर फोर्स काढणार आहे तिथेच आपण बेंडिंग मुवमेंट डायग्राम सुद्धा काढली पाहिजे त्याच्याच खाली. आणि हॉरिझॉन्टल स्केल सेम असली पाहिजे. म्हणजे आपण जर स्पॅनची लेंथ एवढी ठेवत असेल तर शिअर फोर्स डायग्राम आणि बेंडिंग मुवमेंट डायग्रामची लेंथ सुद्धा आपण तेवढीच ठेवली पाहिजे. सो दिस इज अवर guideline 1. So from this point just you have to remember we have to draw shear force and bending moment diagram one below other and we have to make horizontal scale is same. Okay, after that please write down second point. Second point is the dimension on the beam, the dimension on the beam, the dimension on the beam, dimension on the beam, dimension on the beam need not be scaled, 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 but should be relative and proportionate, should be relative and proportionate, should be relative and proportionate, should be relative and proportionate. Should be relative and proportionate, should be relative and proportionate. Okay, under this point you have to remember that okay, so second point is related to the dimension on the beam need not be scaled. That means we have to draw SFD and BMD shear force diagram and bending moment diagram without scale, but it should be proportionate. म्हणजे काय करायचं आपल्याला की 6 मीटर स्पॅन असेल तर तो 6 मीटरच ड्रॉ केला पाहिजे असं काही नाहीये. विदाउट स्केल आपण ड्रॉ करू शकतो, बट इट शुड बी प्रोपोर्शनेट. म्हणजे काय असली पाहिजे, प्रोपोर्शनेट दिसली पाहिजे. जर शिअर फोर्स मध्ये शिअर फोर्सची व्हॅल्यू 2 असेल आणि नंतर 3 असेल तर ते आपल्याला प्रोपोर्शनेट दिसलं पाहिजे, म्हणजे इन्क्रीजिंग ऑर्डरने किंवा डिक्रीजिंग ऑर्डरने. ओके, सो प्लीज रिमेंबर डायमेन्शन on beam need not be scaled. That means scale is not required, but diagram should be proportionate. Okay, please write down next third point. Third point, ordinates in bracket, that is bending moment and shear force values, bending moment and shear force values, bending moment and shear force values, bracket close, need not be plotted to scale, 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 but should be relative, but should be relative, but should be relative, but should be relative, full stop, full stop. Curvature may need, curvature may need, curvature may need, curvature may need to be, curvature may need to be exaggerated for clarity, exaggerated for clarity. Curvature may need to be exaggerated for clarity, exaggerated for clarity. So under this point, you have to remember, suppose we have drawn, this is our beam. Central point load is applied here and shear force diagram is suppose likewise. Shear force diagram is likewise and bending moment diagram is suppose likewise here. So ordinates, that is bending moment and shear force value, need not be plotted to scale. Suppose here WL by 3. Okay. So without scale, but at least we have to draw proportionate. म्हणजे स्केल न घेता ते काय दिसले पाहिजे, प्रोपोर्शनेट दिसले पाहिजे. त्याच्याबरोबरच आपण काय केअर घेतली पाहिजे की कर्वेचर, जर इन्क्लाइंड स्ट्रेट लाईन असेल तर इन्क्लाइंड स्ट्रेट लाईनच ड्रॉ केली पाहिजे. पॅराबोलिक नेचर असेल तर ते पॅराबोलिकच दिसलं पाहिजे. क्युबिक पॉलिनॉमियल असेल तर ते क्युबिक पॉलिनॉमियल. म्हणजे काय लक्षात ठेवायचं आपल्याला की shear force diagram and bending moment diagram ordinates need not be plotted by considering scale, but it should be relative. Okay, and curvature may be exaggerated, that means clarity should be done. So this is our third point. After that, write down next fourth point. Write down next fourth point. Principal ordinates, principal ordinates, principal ordinates, principal ordinates in bracket bending moment and shear force values, bending moment and shear force values, bending moment and shear force values at salient points, at salient points, at salient points should be labeled on both SFD and VMD. 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 Okay. So under this point, you have to remember, suppose you have drawn shear force diagram. Okay, shear force diagram, shear force diagram. So you have to mark the principal ordinates, that is shear force value and bending moment. So shear force at A is W by 2. Here minus W by 2. Here 0. Here also 0. So you have to mark this ordinate. Again, you have to mark in bending moment diagram. So maximum value is here. You have to mark this WL by 4. That means this label is compulsory for at the time of construction of shear force and bending moment diagram. So this is the fourth point. And now last point, that is a clear distance must be made, a clear distance must be made, a clear distance must be made on all straight lines, on all straight lines, on all straight lines, as to whether the lines is horizontal, as to whether the line is horizontal, line is horizontal, or has a positive or negative slope, or has a positive or negative slope, positive or negative slope, positive or negative slope. That means whenever we will draw diagram, whenever we will draw diagram, at that time we have to mark here this diagram is positive or negative in nature. Okay, that means the slope is negative or positive. This point is also you have to remember. So that much points you have to remember for general guidelines on construction of SFD and BMD. म्हणजे काय करायचंय, whenever we will draw shear force and bending moment diagram, at that time first you have to remember, you have to draw SFD and BMD one below the other. Okay, this diagram does not, or dimensions not required. Okay, scale is not required, but diagram should be proportionate. After that, you have to remember the ordinates of bending moment and shear force values should not be drawn by scale. but it should be relative, and curvature is proper. After drawing this, you have to remember, you have to mark principal ordinates. That means the value of that particular point, shear force value and bending moment value. And after that, you have to remember the lines are straight lines, horizontals, or it has a positive or negative slope is there. So all these points we have to remember for drawing or construction of SFD and bending moment diagram. Okay. So today we will stop here. Remaining points we will cover in next lecture. Thank you.